Hey students, so we are on Unit 6, Day 2 video notes. You are going to need your calculator and you are going to need 4 highlighters, 3 for sure, but there's one place where we're going to use 4 and so that's up to you. You could leave the 4th color as no color, but 3 highlighters at least, maybe 4, and then something to write with as well. Okay, so this unit is very, very, very strong in cross multiplying. And there's some things that you'll have to remember from the notes to be able to do your worksheet. There are some tricky spots, but you'll have your notes out and hopefully you'll remember the things that I show you. So first of all, pause your video and copy this down. Grab your highlighters and go ahead and highlight these. It could be different colors. You don't have to use the colors I use, but go ahead and get this done. Pause the video and then you'll be able to jump right in with me. Okay, if you didn't pause the video, go back and do that because I'm going to go on and I'm going to talk kind of quickly. So, in our last unit, we talked about triangles being congruent, figures being congruent, which meant they were the same shape, same size. Well, now we are going into similar. Similar polygons have the same shape, but they are different size. Back in Unit 2, we called these dilations. Okay, dilations had a scale factor and we multiplied by k to change the shape from if k was bigger than 1, the shape got bigger. If k was between 0 and 1, the shape got smaller. So you're kind of familiar with what a dilation is. That's what similar figures are. There's two properties that these polygons are going to have. The sides are going to be proportional. That's your scale factor. Okay? The angles are congruent. I would say out of everything, this is the one students forget. So let's look at this picture down here. When I am looking at this picture, these two figures are similar. They are not the same shape. But if I were to slide this shape right on top of this one, these two angles would be equal. If I were to slide the shape right here and it would cut off about right there, the triangle would fit perfectly here. These angles are equal. And again, if I were to fit them right here, the angles are equal. The angles are equal. The sides are proportional. You have to remember that. So this right here is a big deal for you to know about similar polygons. The sides are proportional. The angles are congruent. All right, this little statement right here that I have a star by, if the polygons are similar, then their perimeters are also proportional, meaning they have a scale factor. Okay, so today we're just going to talk about looking at similarity statements and doing a little bit of algebra. And then the next day it builds a little bit off of that, talking more about similar polygons. Okay, so let's talk about this right here. This little drawing that I have right here goes with the perimeter problems. When you have a perimeter problem, and we will, and I'll point them out to you on your worksheet when you get your worksheet. The setup that you need to remember is that your first fraction, or one of the fractions, it doesn't matter, is your scale factor. So this would be your scale factor, and then the other numbers are the perimeter. Okay, and then of course we're going to have the numbers here for the scale factor, but one of these are going to be a variable, and the question most likely is going to ask you, what is the perimeter of one of the shapes? And so you would have an X in one of these spots so that you could cross multiply and work that out. You're going to have to remember that. You're going to have to remember the setup. Okay, let's go ahead and talk just about basic scale factor. So it says, what is the scale factor of triangle ABC to triangle DEF? So we need to remember that we can write scale factor the 3 ways that we did on the previous notes. We can write it as a fraction. We can write it with the word 2, or we can write it with the colon. Okay, so it says again, what is the scale factor of triangle ABC to triangle DEF? So, what you have to remember about yesterday or the previous notes was that whatever comes first is the first thing you have to write down. Whatever comes last is the last thing you have to write down. It doesn't matter how you write your answers, but you can stick to this way, or you can go back to a fraction. It doesn't matter. Scale factor typically is written as a fraction, but then when we're talking about extended ratios, it's written like this. It's all good. It doesn't matter. I know what you're talking about. So to get the scale factor, we're going to write a little note right here. A scale factor is, and this is a big deal because it's the simplest thing for you to know, but you forget it. A scale factor is just a fraction. Okay, it takes one number from here and one number from here. Okay, one number from this triangle over one number from this triangle. Because it's a triangle ABC first, we have to get the number here first, and then we use this number. Guess what? It doesn't matter if I pick the pink numbers or the orange numbers or the blue numbers. We're going to get the same answer because the scale factor has to work no matter which pair of sides we pick. So if I pick the pink, 8 and 12, and I put 8 to 12, is that reduced? No, it's not reduced. We have to write it as 2 to 3. And I showed you how to reduce that in the last set of notes. I'm not going over that again. So you can write it like that. You can write it like that. It doesn't matter, okay? Because I know that we're talking about scale factors. It's perfectly fine. So you pick any pair. It's just a fraction. Let's write this down. Any pair. All right. So that's one thing that you definitely want to make sure that you're remembering. So, by the way, what happens if I put 10 over 15? I get 2 over 3. What happens if I put 14 over 21? I get 2 over 3. You get the same answer. Okay? So this one says, what is the scale factor? And this is just making sure you're paying attention to details. DEF has to come first. So we could put 12 first, and then ABC would come last. It's just switching it around and knowing that this answer is different from this answer. Depending on which one, it tells you to write down first. So this answer would be 3 to 2 or 3 over 2. Do not put scale factor as a mixed number. Don't put 1 and 1/2. That's not how we write it. Don't put 1.5. You leave it as an improper fraction. Okay, what is the ratio of the perimeter of triangle DEF? Pay attention to which one comes first to triangle ABC. Well, remember what I told you right here, the perimeters are also proportional. They have the same scale factor. I know the answer is going to be the same as this one, but I want to show you. So if I add up all of the sides of this triangle, it gives me 48. Sometimes I will write the perimeter on the inside to show you that it's not one of the outside numbers, it's just all of them together. And the perimeter of this one is 32. So we have to put DEF first. So if I put 48 to 32, and put that in our calculator, 48, ABC, 32. And then remember, we changed this by hitting second ABC. It gives me the same answer. You have to know that the perimeters are proportional. So this is also 3 to 2. Again, if you don't reduce, it is wrong. Okay? All right, let's move on from this. So a similarity statement, we had congruency statements before. The symbol for similar is we drop the equals. Okay, and it's just this because we can't put the equals because then it would be congruent. So the symbol means similar. So a similarity statement matches up all the pieces just like we did with the congruency statements. Write a similarity statement for the triangles above. So if I'm going to just start off with, I'm just going to mix it up. triangle CAB. So if I went triangle CAB, I went blue, pink. I have to go blue, pink with this one. That would be triangle FDE. Okay, and in this triangle similarity statement, it shows me all of the pieces that go together. Angle A corresponds to angle D, angle C corresponds with angle F, angle B corresponds with angle E, and it also shows me the sides that are proportional. AB is right here, goes with DE, and so on. It shows you all the sides. We had this in the last unit, so you should be familiar with that. Okay, so pause the video, and I want you to write all of this down so I can talk about it. Pause the video, write all this down. Okay, so you're getting ready to do one of these on the back, and I want to go over what the similarity statement is telling us, just like we had in the last unit. It tells us the angles are congruent. Okay, so now I would have never thought that this triangle was tipped over. I don't know that it's tipped over and flipped. I don't know what goes with what. This tells me everything. Tells me everything in these two triangles that go together. So I got these answers from up here. Angle J is congruent to angle P. Angle K is congruent to angle M. Angle L is congruent to angle N. The sides are not equal. This is not equal to this. Remember, it's different sizes, but they're proportional. So look at the colors. Look what I did. I wanted to show you that the way I set up these using the letters was showing you that I can make a proportion out of any two of these. And I could say pink over pink equals blue over blue. And I could say, oh, what if I wanted to say blue over blue equals orange over orange? Or I could say pink over pink equals orange over orange. Notice I always went 1 over 2 equals 1 over 2. That is what we're going to be doing a lot of in just a few minutes. Okay, over here, this is an overlapping triangle. There are two triangles. You've got the small triangle, and then if I cover this up, you have the big triangle. All right, so the angles that are congruent, I came up from here, looked up here and got those. By the way, Y is congruent to angle Y because it is overlapping. Y is overlapping with Y. It goes with itself. Okay, and then S goes with Z, R goes with X. They're congruent. Okay, I did not put the colors here, so let's put the colors. The Z, Y, and YS is here and here, just to show you we did orange over orange. And then the XZ was the blue over blue. And then we had the pink over pink. It is really important that you pay attention to those colors because I'm teaching you to do this with colors. And when I tell you when I ask you how did you set it up, I'm going to say, well, you should have gone pink over pink equals blue over blue. And the colors are on there to tell you. Okay, because that's a whole lot easier than saying, oh, you go JK over PM and then JL over PN. You just totally lost what I was telling you. But if you use the colors on your pictures, it really helps you. By the way, notice what I did up here. I highlighted the big pink on the triangle, and the little pink, I put it out here. You need to get used to seeing this because we're going to do this a lot. Okay, the big orange is ZY, and the little orange is SY. Okay. All right, and then notice for this one, I did the big triangle over the little triangle to set this up. Now, if I'd done little over big, I would have to go little over big, little over big, little over big. Just like I could have gone triangle 2 over triangle 1, 2 over 1, 2 over 1. As long as I'm consistent, it doesn't matter. Okay. So what I want you to do is to get your highlighters, use this to highlight the pieces that go together, put the angles that are congruent, should be really easy from here, and then you're going to have 4 ratios set equal to each other. 1, 2, 3, 4, just like we did on the front. So I'm going to ask you one question about this, so have it finished, and then you're going to answer the question. Okay, let's look at what I have on here. So I highlighted the pieces that go together, and I highlighted a side, and then I came up here and found what it went with. And so this is like a rotation. Notice the green and the orange is over here, the blue and the pink is down here. It's been rotated, and they're not the same size, and the scale factor would be a bigger number over a smaller number if we go left to right. Okay. All right, so then looking at the sides that are proportional, I just put orange over orange, blue over blue, pink over pink, green over green, and I stayed consistent. Okay, you will see things like this on the EOC, and you have to really follow what it's asking you to find to see where the pieces are. And so using a highlighter now on your work makes this very easy to do. Okay. Um, so now what we're going to do is we're going to apply finding the pieces that go together to algebra problems. All right. So what I want you to do, at least for the next 4 questions, go ahead and pause my video and get a highlighter and highlight what you see on here. And then that'll help us get through this quicker. And I'll move it up. So pause the video. And then again, pause the video, get some color on there because it's going to make our work a lot easier. Write down these things that I have on the side. Go back and get the other one if you didn't get all of it. Okay, so now you should be ready to go with us. What I have written over here is there are 2 types of ways to start a problem. If they give you a scale factor, you are going to set up a proportion and the scale factor is going to be one of your fractions. That's a big deal. Okay. So if they give you a scale factor, that's going to be one of your fractions. And then the other fraction the other ratio comes from your problem. Okay. Down here, if they give you a similarity statement, like I've got highlighted in blue, you're going to know what to highlight based on from that similarity statement and setting up the proportion. We just got to match the colors up. If you're not using colors, you're making this so difficult on yourself. Okay, so stop what you're doing and grab some colors so you'll know what I'm doing on these problems. Okay, so number 4, if the figures below are similar with a scale factor of 2 to 3. Now, when they say 2 to 3, it's always the left is the first number, the right is the last number. Okay, or top to bottom, 6 is the bigger one. This is the bigger triangle, so it kind of represents this one. 5 is the smaller number. It kind of represents the smaller triangle. Okay, so either left over right or top over bottom when you're setting these up. So what this means is 2 over 3. If you draw these boxes just this one time, okay, 2 over 3 goes in one set of boxes. And then the numbers that are in the picture go in the other boxes in the same order. And all you have to do is cross multiply to get that answer. Now, there's not one on here that has a perimeter, and I hate it that they left it off. But if they said find the perimeter, what they would give you is all of the sides, and you would add all those up and put it here. And then your x would be the perimeter of the next one. Okay. Now think about it. Is this answer going to be bigger or smaller than 42? It's going to be bigger because this is the bigger parallelogram. Okay. All right. Let's cross multiply. So show your work when you're doing your algebra. 2 times x equals 3 times 42. I'm okay if you go ahead and do that in your calculator. 2x equals 126. And then when we divide by 2, x equals 63. Okay, number 5, my scale factor is 6 to 5. If they give you a scale factor, write it down, and then we're going to get the numbers from the rest of the problem from the pictures. So x over 28. You will get decimal answers on your homework, just like we're going to get a decimal answer right here. So 5x equals 6 times 28. And again, I'm okay if you go ahead and multiply that out. I know 5 doesn't go into 168 evenly, so we're going to get a decimal. You can just give me the tenths place. It's okay, 1 decimal place. So x equals 33.8. 6. Okay, so if they give you the scale factor, you write it down as the first fraction. The second fraction comes from the problem. If it's a perimeter, you have to calculate the perimeter and put it in whichever box it goes in. Okay, now the rest of these where I give you the similarity statement, this is how I knew what to highlight. So I've got AB right here, and I look up here. What does AB correspond to? DE. So then I picked up my pink highlighter and I highlighted AB and DE the same color because I wouldn't know what goes with what if I didn't have that similarity statement. So your eyeballs have to go here first before figuring out what goes over what. And then it is so easy. You put pink over pink equals orange over orange. Left over right equals left over right. Okay, so I'm going to go x over 25 equals 28 over 20. Cross multiply x times 20, and then 25 times 28 is 700. Divide by 20, and we get 35 as our answer. Okay, so that should be 35. By the way, if I asked you what is the scale factor, I would put 35 over 25. Okay, 35 over 25 and reduce that, which would also give me the same answer if I put 28 over 20. Okay, because scale factor is just what? Scale factor is what? Scale factor is just a fraction from a pair of colors. Okay, just trying to reinforce that with you. All right, let's look at number 7. All right, so how did I know what to highlight? Okay, how did I know? How did I know these two went together and these two go together? This tells me everything. So this is ZW, and I look up here. ZW goes with SP. And I look down here and I go, there's SP, highlighted those orange, highlighted these another color because the others don't have any numbers on them, so I knew they weren't going to be used. Now, it doesn't matter if I go pink over orange, pink over pink equals orange over orange. If I go top over bottom, or if I go bottom over top, we're going to get the same answer because when you cross multiply, we're cross multiplying the same things no matter which way I set it up. So I'm going to go, I always like to go like top over bottom, top over bottom. So I'm going to go pink over pink equals orange over orange. Pink over pink equals orange over orange. And I went top over bottom, top over bottom. You have to stay consistent. All right, so this is going to be 40 times x. 32 times 75 is 2,400. Divide both sides by 40, and we get x equals 60. Just to reinforce it one more time, if I asked you what is the scale factor of this picture, I would go PQRS first, so they're asking this one first. So I would put orange over orange, 75 over 40, and simplify, or I could put 60 over 32 and simplify, because scale factor is just a fraction. One number from here over one number from here. Okay, number 8. I am actually going to, you've got the highlighting done. I'm going to tell you, I'm going to put pink over pink equals orange over orange, left over right equals left over right. I want you to work this out. You should not get a decimal. It's just going to test your algebra skills. So go ahead and work this one out, and then I'm going to put a question in here seeing if you got it right. So go ahead and do that now. Okay, here's the answer to number 8. Cross multiply, I did 36 times x plus 3. Remember, if you write it out like this, you're less likely to make a mistake. 32 times x plus 6. And then I distributed, did the regular algebra that we've been doing for 9 weeks now, and I got x equals 21. Okay? All right. Number 9, let me go ahead and set it up for you. So I'm going to put orange over orange equals pink over pink. Remember, I went left over right, so I have to go left over right. Okay, I want to teach you something. So to help you with the math. Okay, you are perfectly fine to take this problem and go 25 times this and 10 times this and work it out just like we did here. Okay, nothing wrong with that. But if you want to be a better math student and always find the most efficient way to do something, remember we get the scale factor from making a fraction out of one pair of sides, and scale factor can be reduced. Can this fraction be reduced? Yes. So if I multiplied the 25 times this and the 10 times this and I worked it all out, I would get the same answer as if I had reduced 5 goes into 25 5 times, 5 goes into 10 2 times. If I distribute these numbers, I can do the work in my head and I don't need to pick up my calculator. Okay, so what I'm going to do is I do have the problem worked out. I'm going to go ahead and work it out with these smaller numbers and then show you that I got the same answer with the bigger numbers. Okay, so let me show you. So if I go 5 times x plus 5 and 2 times 4x minus 1, okay, I like this because I can do all of this in my head. 5 times x, 5 times 5 is 25, 2 times 4 is 8x, 2 times negative 1. There's nothing that I needed to pick my calculator up for. Okay, I'm going to subtract 5x. I subtracted 5x from both sides, and then I'm going to add 2, and we get x equals 9. Show the work if you need to show the extra steps that I'm leaving out. X equals 9. So, just to show you the difference between this and this, I had bigger numbers, but I had the same answer. So when you are checking your answers on my answer sheet and you see me do this, that means I made the problem easier and I did the work with the easier numbers. You are not required to do that. You should still get the same answer that I get. Okay? All right, good job on the notes. These will be checked. Everything should be filled out 100% to get a stamp on the notes. If you don't have your notes 100% filled out, then you need to go back and watch this video again and get them filled out. And one last thing, would you please go into Google Classroom and mark as done to get it off your to-do list. Thank you, students. You're awesome. I love having you in class. We will do the next worksheet the next time that I see you.